So first run has been completed. These are the warning messages and information messages that has been encountered during the analysis. The warning messages here also. So after completion of the first run, what I need to do, that is I have to change the scale factor for the static earthquake and the dynamic earthquake forces. So I will go to the display and story response plot. Here I will go for the story shear, and in place of dead load I will select the EX load, that is earthquake in X direction in static format. Here the base shear is coming 2615.46. we'll note it here. This is 2615.46195.1. This is for the X direction. Same way I will calculate for the Y direction also. So now I will change it to the EY. So for EY it is coming as 2967.386295. Here it is showing. This is in kilonewton, force in kilonewton. This is the base shear forces. So now I will check the specific force. Specific force is coming is 169 kilonewton only. So I need to scale that factor. So divided by 169.5020, sorry, 502059. So this is the scale factor that I need to edit. And same way for spec Y also I will find the scale factor. So this is 146.742713. So this is the scale factor. Now for both the EX and spec X and UI and spec Y, I have calculated the scale factor that I need to edit here in the response cases. So initially it is 1000. Now it's time to multiply the value. This is 15.43026. 15.43026. 43026. This is the scale factor. Now click on OK. Again for spec Y also same way I will change the scale factor. 20.22169, that is 20.2217. 20.2217. Now again I will go for the analysis. So this will take time. So again after completion of the second analysis, first thing that I will check, I will go for the response spectrum, story response plot, and I will check the base share value. For EX, it was 2615.46. For spec X, 2615.46. Same value has come. And for UI, it was 2967.38. Spec Y also 2967.38. So the scale factor, we have changed scale factor successfully. Now it's time to see the deflection value, the deflection due to the gravity forces. So for that I will go to the show deform shape value. Now for seeing the deflection value, or for checking the deflection value, first I need to define the load combination for the service load D1 plus L1. Okay. So I will check the deflection value for the dead load and live load. Here I will go for the displacement UZ because it is in the gravity direction for the gravity loads such as dead load and live load. So here you can see the maximum value is 9.19 mm unit, 9.19 at the story level, 25 story height 25.5. So 9.19 at 25.5. So I will go to the terrace value. Terrace height is 23. So the OHT value is 25.5 meter. So here the maximum deflection is 9.19. So I will check it. 9.19. Here the value is coming 9.19. I note it. .19 is the deflection value here. And also I will deduct the axial shortening here, 6.656, 6.861. I will go with this value, 6.656. Minus 6.656. That will be multiplied with 3 for the creep. So maximum allowable deflection can be 7.60 mm. Now I will check the shortest distance, because this is the this side the length is 3.95 and this size the length is 4.875. Here I will check it. So define and draw dimension line. What is the value here? 3.625. Here 3.625 in this side the length, and here 3.95. So I will check for it. 3.625. So 3.625 divided by 350 So maximum allowable as per code is 10.35, maximum allowable deflection 10.35. And here, with considering the creep coefficient, it is comes as 7.60. So the value is the deflection value is under control, it is not beyond the maximum permissible value, so the deflection value is under control. After checking the deflection value, the next thing that I need to check is the modal analysis for the uncracked model. So for checking the modal analysis, I will go for the mode 1, and here it will be displacement resultant. I will click on apply, and I will go to the plan value of terrace. So this will be the first mode movement. I check the animation here. This is in the y direction, and second mode is in the x direction, and in a third mode it is rotation. So the modal behavior is perfect for this building. Anyway, I will check the result also. So for first mode, the fundamental time period is 0.84 second. Here the number of story is 1 2 3 4 5 6 7 8. So the fundamental time period should not be less than 0.8. Here it is 0.84. So it is more it is quite stiff actually. Anyway, we can go up to 1 meter 1 second also, fundamental time period. Anyway, so let's check the values, result actually. Modal participating mass ratios. Under the modal information, under the structure output, the analysis result. Here click on OK. This is the modal analysis result. Here the fundamental time period is 0.842 seconds for the first mode, and the contribution in the UY it is 70%, and in RZ it is 4%. So this mode, in the first mode, it is the rotation or the torsion is less than the 5%, so it is okay. And in the second mode, it is the fundamental second mode time period is 0.74 second, and the third mode time period is 0.64 second. In the second mode, it is coming under the UX direction with 69% contribution, and in the rotation it is 5% contribution. In mode 3, 69% contribution in the RZ, and the some UX and some UI after third mode, 75% in UX direction and 73% in UI direction is mass contribution is happening. And after the 18th mode, 96% and 98% mass contribution is happening. So bending is quite stabilized after bending is stabilized after the 18th mode, and it is all as per the codal information. Again, I will check the minimum gap. So as per the code, third mode is the rotation mode. Anyway, we will check for all the modes. So 0.842 into 0.9, sorry, 0.842 into 0.9. So the second mode time period should not be more than 0.7578. It is 0.74, that is, it is less than 0.75 second. So the 10% gap has been maintained here in between the first mode and second mode. Same way I will check for the second and third mode also. 0.741 into 0.9. So the time period for the third mode, it should not be more than 0.661, 6669, 0.66 second. It is 0.64 second coming. So the gap, the time period gap of 10%, it has also been maintained here. So in all respect, the modal analysis has been quite impressive. I will check nothing here. So in uncracked model, generally I will check these two parameters here. One is the deflection and another is the modal analysis. So after completion of these two checking, the next step that I will go to the go for the SMF in the service mode, and then I will go for the SMF for the strength mode, and in the service mode there will be different checkings, and in the strength mode also there will be different checking. We will see it in the next videos. Thank you.